It's in day 2, GCF factoring. At the very top, remember that I asked you to carve up your first page into 3 equal rows, so right up here at the top. If up at the top you would label that Roman numeral 1, write down prime factorization, and then copy that into the definition for prime numbers. A prime number is any number that is only divisible by 1 in itself. Okay? Well, in order to do prime factorization, you start with a number, like let's say 98 here. We want to break it down into its prime components. It's like you're kind of breaking it down all the way to where you can't break it down anymore. Okay? Well, one way you guys have done this in the past is with a factor tree. And you guys have seen this before. You start with something like a 98, and then you begin to think about some primes that go into 98. For instance, a 2 divides into 98, and it does it 49 times. Okay? Well, the 2 is a prime. So this is going to be a part of our prime factorization. The 49 is not a prime. It can be broken down a little bit further. It's 7 times 7. Well, 7 and 7 are both primes. The 3 numbers that we circled there at the end of the branches are what go into the prime factorization of 98. So we would write this as 98 equals 2 times 7 times 7. And that is 98 broken down into its 5 prime factorizations. Another way that you guys might have done it in the past is by what's called a ladder diagram, or some of you guys might have heard it called an upside-down birthday cake. But the idea is very, very similar to what we just did a moment ago. We start with 60 and we say, okay, let's pick a prime like 2, and let's see how many times it goes in there. Well, it goes in there 30 times. Then we see if we can do it again. 2 times 15. Okay, then 15 breaks down to 3 and 5. All these numbers that are on the outside of this ladder or upside-down birthday cake, all of these numbers I'm circling now, these are going to be the primes that go into the prime factorization. So we could write that 60 is 2 times 2 times 3 times 5. Okay. Well, let's say that we want to find the greatest common factor between 2 numbers or 2 terms. Well, we use our prime factorization in order to do that. And this is what it looks like. By the way, we are now on our front page where you have your 3 rows, are right in the middle. Go ahead and label this guy Roman numeral 2 and put GCF, greatest common factor. Go ahead and put A, and let's write down integers. And the 2 examples I want to do first here are 12 and 32. I want to find the greatest common factor of those 2 numbers. And the way that we can do that is by taking each one of those numbers and breaking them down into their prime factorizations. Okay, 12 would be 2 times 6, and then the 6 would break down to 2 and 3. So we end up with 2, 2, and 3 for the prime factorization of 12. 32 will be broken down into, let's see, 2 and 16, 2 and 8, 2 and 4, and 2 and 2. So that means 1, 2, 3, 4, 5 different 2s. As you're writing down these prime factorizations, you'll notice that they share some common factors. They share 1 pair of 2s here, and they share another pair of 2s here, and then that's the only thing that they share. If you make a list of all the things that they share, in this case 2 2s, what you'll get is their greatest common factor. So the greatest common factor is, let's see, they share 1 2, 2 2s, so it's 2 times 2 or 4. The greatest common factor that goes into both 12 and 32 is 4. Okay? Let's try down here with 26 and 52. Take a moment to write down those 2 numbers. Write down the prime factorization, pause the video, and let's see if you get the correct greatest common factor. Okay, 26 is 2 times 13. 52 is 2 times 2 times 13. What they share is a 2 and a 13. So the GCF is going to be the product of those 2 numbers, 2 times 13 or 26. In other words, the biggest number that goes into both 26 and 52 is 26. All right, well, let's go over here to the right and add a little bit of algebra. And you can see now that some letters are starting to show up, X's and Y's and so forth. Okay, well, we're still going to be doing the same thing. We're going to be trying to look and see what factors do both of these two terms share. So, for instance, as I look at A here, by the way, remember on your paper, just label it B binomials and draw yourself a little line right here down the middle. And let's just start with A. And I've got 15x to the third. All right, well, 15 is 3 times 5. Those are both prime numbers. Well, what do we do about that x to the third? Well, if we break down x into its prime components, it's just x times x times x. All right, 9x squared. 9 is 3 times 3. And then x squared is just x times x. Then you look and see, okay, what do they share? They share a 3. They share an x. And they share another x. So their greatest common factor is going to be the product of those three things. So the greatest common factor is 3 times x, or 3x squared. Okay, let's try B. 100x squared. Why? Okay, well, 100x squared, y. Well, 100 is 2 times 50. 50 is 2 times 25. And 25 is 5 times 5. Then we have x times x, which is the x squared, and then the y. Okay. Negative 60xy to the third. Okay. Let's talk a little bit about what we need to do with that negative. Whenever you guys see a negative on one of the terms, the first number you need to write down is just write down negative 1. And then we don't have to worry about that negative anymore. Now I'm just going to worry about breaking down a positive 60. All right, well, 60 is 2 times 30. 30 is 2 times 15. And 15 is 3 times 5. Times x. And then I've got the 3 y's. Let's see what they share. They share a pair of 2's. They share a pair of 5's. An x and a y. Okay. So the GCF there will be 2 times 5 times x times y, or 10xy. Oh, you know what? Look up here. Come on, Mr. Goethals. There's another 2 they share up there. So that'll be 2 times 2 times 5. That's 20xy. That sounds more like it. Okay. On the last example on C, you have negative 18g squared and negative 27g to the third. On the bottom there, you get a little bit of extra room, hopefully. Do their prime factorizations. Use the 2 above this as a guide. And see what you can come up with on your own. I'll check this when you guys get into class the next time I see you. Okay? When you get done with that, go ahead and go down to the bottom. On your notes, of our 3 equal rows will be down here at the bottom. Put a little Roman numeral 3, okay, and put distributive property. And then I want to talk a little bit about what we're trying to do with all this. So far, what we've done is multiplication. And so you'll start with something like, let's say we have 4 times 2x plus 3. Well, we know that we can simplify that by doing a little distributive property. And we end up with 8x plus 12. Well, what I want to be working on today is going back the opposite direction. So if I was to give you 8x plus 12, I would want you to realize that 4 is the largest number, or the greatest common factor, that divides into 8 and 12. So we would actually extract that, or take that out of the expression. So 8x plus 12 would turn into 4 times 2x plus 3. Okay? Flip your paper over the back. Got a little bit of writing here to do. You're welcome. Remember that I had you guys in class? Go ahead and draw a little line down the middle. Over here, draw yourself a little circle. Fill in factoring polynomials by GCF. And then do the formal definition on top. And do the informal definition on the bottom. In other words, copy down those words on your paper. If you have any doubt, try to make it look just like mine. All right, pause the video, go ahead and copy it down, and we'll do a couple examples over to the right. I like the informal definition at the bottom because it basically tells you what to do. if I want to take an expression like this 2x squared minus 4, and if I want to factor that expression, I'll follow these instructions. The first thing I'll do is I'll find the GCF of each one of the two terms. And then I'm going to put it outside the parentheses. And I'm going to divide it from each one of the terms that were on the inside. Okay? Let me show you what that looks like. Here I've got two terms, 2x squared and a minus 4. So I'm going to go ahead and do my prime factorization like we did earlier. And I'm going to see what these two guys share. Well, 2x squared is just 2 times x times x. Negative 4 is, well, there's the negative 1. And then 4 just breaks down to 2 times 2. The only factor that each one of these share is the 2. So there's your GCF. Okay, now, that is what I'm going to factor out of this expression. Okay, so here's what it's going to look like. Once you found your GCF, that's going to go right on the outside of the parentheses. So I'll put it on the outside of the parentheses. Then what I'm going to do is I'm going to take each one of those two expressions, the 2x squared and the minus 4, and I'm going to divide each one of those two terms by the GCF. In other words, I'm going to be taking a 2 away from each one of those two terms. Well, you can see here on the first term that those 2's cancel out. And what we end up with here is, well, there's the 2 on the outside. We end up with x squared. And on the other term, we have 4 divided by 2. Well, that's just 2. And we end up with an expression here that is the same value as what we started with, but now the GCF has been taken out of the expression. You can see that I could go back the other direction, do a little distributive property, and end up right where we started. Okay? Let's try the next one. 8x to the third minus 4x squared minus 16x. I have 3 different terms there. I'm going to do the prime factorization of all 3 terms. All right, so 8x to the third. That's going to be 2 times 2 times 2 for the 8. And then I've got 3 x's. Minus 4x squared is negative 1 times 2 times 2 times your 2 x's. And then negative 16x. There's the negative 1. And then 16 is 2 times 2 times 2 times 2. And then the x. Now keep in mind, I did the factorizations of these earlier, so I know that I'm going a little fast, but I'm also trying to make the video a little bit shorter for you. Okay, so as I look at these 3 different prime factorizations, I'm looking to see what they share. Okay, well, I know that they all share one of these 2's. And actually they share another triplet here of 2's. They all share 1x. And as I'm looking around here, I don't think that there's any other number that all 3 of them share. A couple of them have a negative 1, a couple of them have a 2, and a couple of them have an x, but not all 3. So the GCF of this one is going to be 2 times 2 times x, or 4x. That's the expression, that 4x is what I'm going to take out of this trinomial. And it's what's going to be on the outside of my parentheses. Okay. Now, in order to do that, I'm going to have to divide each one of these guys by 4x. So let's see what happened here. On the outside, I got 4x. Then I've got 8 divided by 4 is 2. And then x to the third times x to the first gives me x squared. I'm over here on the middle term. 4 divided by 4 just gives you 1. And then x squared divided by x to the first just gives you an x, or x to the first. Then the last one, negative 16 divided by 4 gives you negative 4. And then also the x's cancel out too. Okay? So we end up with just this expression on the inside. Now we should be able to check our answer in these and go back the other direction and do our distributive property. So let's just see if we actually do get the correct answer here. Okay, so by doing the distributive property there, I was able to start off exactly where I started. Okay. Our goal is, though, is not to multiply. Our goal is to factor out the greatest common factor. Okay? All right, there's 3 of these on the bottom. Now you have 2 examples here. I want you guys to be able to do these on your own. So I left you basically the bottom half of the page here to write these 3 problems down. These 3 problems I want to look at when you guys walk in the room next time I see you. Now, if you have no clue and you're completely lost, come in and see me. We can sit down and work these problems together. If you got a pretty good idea and you want to try it on your own, please do. But make sure you guys can walk in the next time I see you and be able to work on this type of concept. Okay? Well, come and see me if you need some help. Thank you very much.